Hi students, welcome back to science class. You have studied about different types of compounds in your previous classes, right? Okay, and in today's class, you are going to familiarize a new class of compounds named organic compounds. Organic compounds. Organic compounds means carbon and its compounds. Carbon and its compounds. So organic compounds are the general name of carbon compounds. And the branch of science which deals with the carbon and its compound is organic chemistry. So organic chemistry is the branch of science which deals with carbon and its compounds. Okay, in fact, carbon is very important to us. In chapter 3, we have studied about metals and non-metals. The important non-metal is carbon. Carbon is one of the very important non-metal. Why? Because carbon is essential in the elemental form and in the combined form. So carbon is very essential for us in the elemental form and in the compound forms. In fact, carbon is a versatile element. Carbon is a versatile element. Carbon has very important qualities which helpful to us. So in the chapter carbon and its compounds, we will study about the properties of carbon and what versatile nature shown by the carbon, etc. In spite of the versatile nature of the carbon, the amount of carbon present in the earth crust and in the atmosphere is very low. Earth crust has only 0.02% of the carbon in the form of minerals and atmosphere has only 0.03% of the carbon as carbon dioxide. In spite of the small amount of the carbon, carbon is very essential and it is very useful to our lives. Let's discuss why carbon known as the versatile element. Okay, as you know, ionic compounds or the ionic bond is the bond formed by the transfer of electrons. Ionic bond is the bond formed by the transfer of electrons. So what is ionic bond? Ionic bond is the bond formed by the transfer of electrons, and such compounds are known as ionic compounds, and ionic compounds show high melting and boiling point. Why they show high melting and boiling point? Because ionic bond is the strong bond. It's a very strong bond. Ionic bond is very strong bond. So ionic compounds shows high melting and boiling point. And also ionic compounds conduct electricity in their molten state. So ionic bond is the bond formed by the transfer of electrons and it is the strong bond, and ionic bonds or ionic compounds show high melting and boiling point because the bond between them is ionic bond, and ionic bond is the strongest bond, and ionic compounds conduct electricity in their molten state. Okay, but when we talk about carbon compounds has very less boiling and melting point. Carbon compounds shows less melting and boiling point, and carbon compounds are poor conductors of electricity. Carbon compounds has very less melting and boiling point, and also they are poor conductors of electricity. So if carbon compounds show very less melting and boiling points, which indicates the least strength of the bonds. So the bond between the carbon compounds, has very weak bond. So why carbon compounds shows less melting and boiling point? because the bond between them is weak. So the bond between them is weak. Weak means only very less amount of energy we need to supply to break this bond. That's why they show less melting and boiling point. Right? If the melting and boiling point is high, which indicates the strength of the bond, which means the bond should be if the high melting and boiling point, which indicates the high strength of the bond. So in case of carbon compounds, if they shows very less melting and boiling points, which indirectly tell you the bond between them is very weak. And also, if carbon compounds are poor conductors of electricity, means what? They are not producing ions. As you know, ions are the responsible factor for the conduction of electricity. Why the ionic compounds conduct electricity in their molten state? Because in the molten state only they produce ions. So if the carbon compounds are not conducting electricity, or they are poor conductors of electricity, means they are not providing or producing ions. If they are not producing ions, they cannot conduct the electricity. So which type of bond between the carbon compounds? That is our next discussion points. So what type of bond between the two carbons? What type of the bond between two carbon atoms? 2 points related with this, that is carbon compounds has very less melting point and they are poor conductors of electricity. Okay, and that we have discussed earlier that the ultimate aim of an element is to attain octet configuration, or filling their last shell, the valence shell, with 8 electrons. So in order to attain octet configuration, or in order to fill the 8 electrons in their outermost shell, elements have 2 possibilities or 2 chances, like either they can accept electrons or they can donate electrons. These are the 2 ways for an element to attain octet configuration. Either they can accept electrons or they can donate electrons. But in case of carbon, what is the atomic number of carbon? The atomic number of carbon is 6. The atomic number of carbon 6. So how to write the electronic configuration? 2, 4. This is the electronic configuration. So in case of carbon, there is equal chance for accepting or donating electrons. If carbon needs to accept electrons, how many electrons carbon should accept? 4. That is 4 plus 4, 8. So in case of donating, carbon should donate 4 electrons. So in case of carbon, the number of, the case of accepting or electron are both the same number, which means if the carbon need to accept electrons, it need to accept 4 electrons, or if it donate electrons, same number. Okay, so now we can discuss, suppose you just consider carbon wish to accept electrons. Suppose if the carbon is accepting electrons, what will be the number of electrons for the carbon? At present the carbon has 6 protons and 6 electrons. Why? Because atomic number is the number of protons. Atomic number means number of protons. That means if there is 6 protons, there should be 6 electrons. So by knowing the atomic number, what are the other points we will get? Atomic number is the number of protons. So in case of carbon, the number of proton 6. And what about the number of electron? Same 6. Only they differs in their sign. Means protons positive and electron negative. Which means if the carbon accept electrons, there should be 10 electrons. How? 4 plus 2, 6. 6 plus 4, 10 electrons. And what about the number of protons? Number of protons same. Only the carbon is accepting electrons. There is no change in the number of protons. Is there any change in the number of protons? No, there is no any change in the protons, only change in the number of electrons. So if the carbon accepting the 4 electrons, there is 10 electrons and 6 protons. So it would be difficult for the nucleus of the carbon to hold this 10 electrons around. So in case of carbon, if the carbon accepts 4 electrons, there is 6 proton in the nucleus. Where you can see the protons? You can see the protons in the nucleus and electrons are revolving around the nucleus. So if the carbon accepting 4 electrons, there should be 6 electrons in the nucleus and 10 electrons are revolving around the nucleus. That would be difficult for the nucleus. So if the carbon accept electrons, 4 electrons, the nucleus with 6 protons, it is very difficult for the nucleus with the 6 electrons to hold this 10 electrons. Already I told you there is 6 protons in the nucleus, and when the carbon accepts 4 electrons, there should be 10 electrons. So it would be difficult for the nucleus with the 6 protons to hold this 10 electrons. That's why carbon cannot accept 4 electrons. Why carbon cannot accept 4 electrons? Because if carbon accept 4 electrons, there is 10 electrons. So it would be difficult for the nucleus with 6 protons to hold this 10 electrons. That's why, because carbon is a small element. Carbon is a small element. So the nucleus of the carbon feels difficulty to hold this 10 electrons around it. Already there is 6 protons in the nucleus, and accommodating this 10 electrons around it would be very difficult. In that case, carbon cannot accept 4 electrons. Okay, so what about in a case of donating? If carbon donates 4 electrons, suppose if carbon donates 4 electrons, it requires huge amount of energy to donate this 4 electrons. If carbon needs to remove its 4 electrons from the last shell, it requires large amount of energy. So why carbon cannot, donate its 4 electrons? Because for donating its 4 electrons, it requires large amount of energy. That's why carbon cannot accept electrons and cannot donate the electrons. So normally, what is the way for the elements to attain noble configuration? Now, octet configuration, either by accepting or donating. But in case of carbon, both chances not possible. Why? If the carbon accepts 4 electrons, it would be difficult for the nucleus with the 6 protons to accommodate this 10 electrons. But if the carbon donates its 4 electrons, it requires large amount of energy. Then how the carbon, solve these problems? How carbon find a way to, avoid this situation? Carbon overcome this problem by sharing electrons. So how the carbon, attain an octet configuration? Carbon attains its octet configuration by sharing the electrons. So I told you, ionic compound is the compound formed by the transfer of electrons. And now you are going to study a new compounds or a new type of bond formed by the sharing of electrons. So the bond formed by the sharing of electron is covalent bond. So covalent bond is the bond formed by the sharing of electrons between the atoms. So what are covalent compounds? Covalent compounds are the compounds which have covalent bond. Right. So what is covalent bond? Covalent bond is the bond formed by the sharing of electrons between the atoms, and such compounds are known as covalent compounds. Covalent bond is the bond formed by the sharing of electrons between the atoms, and such compounds are known as covalent compounds. And covalent bond is the weak bond. Because of that, they shows very less melting and boiling point. So once again, covalent bond is the bond formed by the sharing of electrons between the atoms. Let's discuss some examples. First, we can start with the hydrogen. What is the atomic number of hydrogen? The atomic number of hydrogen, 1. Atomic number of hydrogen, 1. That means hydrogen contains only 1 electron. Hydrogen contains only 1 electron. So this hydrogen can share its another electrons with another hydrogen atom. See, in case of hydrogen attains stability by filling 2 electrons in the outermost shell. In case of hydrogen, how many electrons required to become an octet configuration, or how many electrons needed to become a stable element? In case of hydrogen, hydrogen requires only 2 electrons. So this hydrogen can share its electrons with another hydrogen atom. See. So in case of this hydrogen, 2 electrons, and for this hydrogen also 2 electrons. So how many electrons needed for the hydrogen atom to become a stable element? Hydrogen requires only 2 electrons. So how hydrogen occurs that one hydrogen can share its electrons with other hydrogen. See, for this hydrogen, here it is 1, and for this hydrogen also 1. So this hydrogen can share 1 electron of other hydrogen, and this hydrogen can share 1 electron of other hydrogen. That's why we have to write hydrogen always H2. Why we have to write hydrogen in diatomic form? Hydrogen is a diatomic molecule. Why? Because when hydrogen in the diatomic form only, it acquires stability, because 2 electrons require for the hydrogen to become a stable element. So that attaining stability by sharing electrons with other hydrogen atoms. That's why when we write hydrogen as H, it is not a stable element. Why? Because for this hydrogen there is only 1 electron. How the hydrogen become a stable element? If hydrogen gains 2 electrons, or if there is 2 electrons, only hydrogen gets its stability. That's why you have to write hydrogen in the diatomic form. That's why we have to write H2. So don't forget this. Why we have to write H2? Because if you are writing H2 only, it attains its stability. Why? Because there is a covalent bonding between 2 hydrogen atoms. One hydrogen atom can share its electrons with other hydrogen atom. So in case of this, 2 electrons, and for this hydrogen also 2 electrons. So that's why H2. Okay, so another very important point, this line is bond. So at least 2 electrons require for the formation of a bond. So how many electrons require for a bond? 2 electrons. So if there is 2 bonds, 4 electrons. If there is 2 bonds, 1 bond, 2 electrons. 2 bonds, 4 electrons. 3 bonds. Okay, so there are 3 different types of bond. If there is only 1 line, single bond. If there is 2 line, double bond. If there is 3 line, triple bond. So 3 different types of bonds are there. 1 line, single bond. 2 line, double bond. 3 line, triple bond. How many electrons for a single bond? 2 electrons. How many electrons for a double bond? 4. 2, 4. And how many electrons for a triple bond? 6. So how many electrons require for a bond? A bond, 2 electrons. There is 2 electrons for 1 bond. If there is double bond, 2 electrons, 4 electrons. If there is triple bond, 6 electrons. Okay, so keep these points in your mind. If there is only single bond, 2 electrons. If there is double bond, 4 electrons. If there is triple bond, 6 electrons. So at least 2 electrons require for a bond. So why hydrogen attains in the form of, or it is in the form of H2? Why the hydrogen exists in the form of H2? Because in the form of H2 only it attains its stability. Because these hydrogen atoms are sharing their electrons. Okay, so what about in case of chlorine? See, in case of chlorine, the atomic number of 17. 2, 8, 7 means chlorine requires 1 electron. So right, how many electrons should be there in its outermost shell? 7. So Cl. 2, 4, 6, 7. Another chlorine. Okay, 2, 4, 6, 7. So this chlorine requires 1 electron. So see, share it. 2, 4, 6, 7, 8. 2, 4, 6, 7, 8. So one chlorine shares 1 electron of other chlorine, and this chlorine shares the electron of this chlorine. So there is a bond between Cl. See, 2, 4, 6, 8. 2, 4, 6, 8. That's why Cl, Cl2. Why you have to write Cl2? Because in the form of Cl2 only chlorine attains its stability. Because chlorine requires one electron, so this chlorine can share the electron of opposite chlorine and this chlorine can share the electron of this chlorine, right? 2, 4, 6, 7, 8. 2, 4, 6, 7, 8. So Cl2. Okay, which bond between two chlorine atoms? Single bond. And how many electrons require for a single bond? 2 electrons. Okay, so now we can discuss about oxygen. What is atomic number of oxygen? 8. 2, 6. How to write the electronic configuration? 2, 6. So how many electrons in its outermost shell? 6. So how to show it? 2, 4, 6. Another oxygen atom. 2, 4, 6. This oxygen atom requires 2 electrons. So this can share the 2 electron of this oxygen. See? And this oxygen can share this 2 electrons. Okay? 2, 4, 2, 4, 6, 8. 2, 4, 6, 8. So which bond between two oxygen atom? Double bond, O2. So that's why O2. So why we have to write oxygen as O2? Because sharing. This oxygen share 2 electron of this oxygen and this oxygen share the 2 electron of this oxygen. That's why O2. So which bond between two oxygen atom? Double bond. Which bond formed between the two oxygen atom? Double bond. Okay. How many electrons require for double bond? 4 electrons. For the single bond? 2 electrons. For double bond? 4 electrons. Okay. Then let's see the nitrogen. How we can write the sharing of nitrogen. See, what is the atomic number of nitrogen? The atomic number of nitrogen 7. The atomic number of nitrogen 7. So 2, 5. How many electrons in the outermost shell? 5. So see, in case of nitrogen there is a way to write the electrons. So you have to write 3 electrons together and 5. And 3 electrons. Then only you will get the correct bonding. Okay. So 5, 3. See. Very simple. So bond. So which bond between the nitrogen atom? Triple bond. That is N2. How many electrons? 6 electrons. 3 bond, 6 electron. Triple bond. Triple bond. So single bond 4 electrons, triple bond 6 electrons, 2, 4, 6. And what bond between nitrogen atom? Triple bond. How many electron for the triple bond? 6 electron. Which are the 3 different bonds? Single bond, double bond, triple bond. How many electrons for a bond? 2 bond. If it is double bond, 4 electrons. If it is a triple bond, 6 electron. The bond between nitrogen atom? Triple bond, N2. The bond between oxygen atom? Double bond, O2. And the bond between two chlorine? Single bond. Okay. And let's see how we can write water. How we can write the, water. What is the formula of water? H2O. So how to write HOH? And what is the what is the atomic number of oxygen? 8, 2, 6. So 6 electrons. 2, 4, 5, 6. In case of hydrogen, 1 electron. So how to share? Okay, so 2 electron for hydrogen. Here also 2 electron for hydrogen. And 2, 4, 6, 8 for oxygen. See? 2, 4, 6, 8 oxygen. 2, 4, 6, 8. First circle hydrogen 2. This 2 for hydrogen. And this 2 for hydrogen. So when we round as a whole, 8 electrons for oxygen. Okay, hydrogen 2 electrons. So this is hydrogen. Okay, and 2, 4, 6, 8 for oxygen. So 8 electrons for oxygen and 2 for hydrogen. So oxygen, hydrogen become a stable. So they shared the electron. So that is water. That is water. Okay, then what about carbon dioxide? See, how to write the carbon dioxide? What is the formula of carbon dioxide? CO2, right? So, COO. 6 electron, 4 electron for carbon, right? Carbon 6, 2, 4, carbon. And oxygen 2, 6. Okay, so 4 electrons for carbon, 2, 4. And 6 electrons for oxygen, 2, 4, 6. 2, 4, 6. So I have to share oxygen 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Then what about carbon? 2, 4, 6, 8. So 2, 4, 6, 8. Okay, so you can see double bond. So C, this is carbon dioxide. C double bond. And water, HOH. Water, HOH, carbon dioxide, C double bond. This is the carbon dioxide. How? First 4 for carbon atom. Then 6, 6 for oxygen. Then oxygen share 2, 4, 6, 8. 2, 4, 6, 8. Then for carbon 2, 4, 6, 8. All round. Okay, so this is the way of sharing. So these all the compounds are very important. Okay, so what is covalent bond? Covalent bond is the bond formed by the sharing of electron. Covalent bond is the bond formed by the sharing of electron. Such compounds are known as covalent compounds. Okay, and that's all about today's class. We will discuss other points in our next video. Till then, it's bye. Thank you for watching. Have a wonderful day ahead.